Hello everyone! Welcome to 5.4 Medians and Altitudes. Let's get started. The first thing we want to talk about is the median of a triangle. A median is segments whose endpoints are a vertex and a midpoint of the opposite side. So, I will show you with the diagram in just a second. A segment whose endpoints are a vertex and the midpoint of an opposite side. That's the median. A centroid is the point of concurrency, all right, where they meet, where the medians meet, of the medians, and it is always inside of a triangle and always the center of gravity for a triangle. So when you think of a centroid, I want you to think of it as the point of gravity of a triangle. It's the center of a triangle. Right? You could balance something at that point of a triangle. The other special property is the centroid is it's 2/3 the distance from each vertex to the midpoint of the opposite side. So where the centroid meets in the center of a triangle, all right, right here at point C where they meet, this would be the centroid. Okay, from the vertex to the centroid is 2/3, all right, and then from that centroid to the other side would be 1/3. So right here, this would be 2/3, and this would be 1/3. So think of medians. They come from a vertex to the midpoint of the opposite side. So there's some congruencies that are created from K to L and L to D, and the same over here from K to M and M to T, and over here from B to T and B to D would all be congruent. Okay, so the point of concurrency, C. So if I were to tell you that the whole segment MD was 12 units long, well, from DC, that would be 2/3, right? From the vertex to the centroid would be 2/3. So the distance from D to C would be 8, and the distance from C to M would be 4. All right, so 2/3 and 1/3. We'll do more practice problems like this in class. And then again, if we're looking at TC, and we know that the whole, and we know that from T to C that it's 6, and I wanted to know that whole TL, well, if this is 2/3, then another 1/3 would be 3, so 6 plus 3 would be 9. Okie doke. And then we're going to move on to the altitude of a triangle. I'm having a hard time speaking during this video. It's the perpendicular segment from a vertex of a triangle to the line containing the opposite side. It can be inside or outside of a triangle, the altitude can be. So it basically measures the height of a triangle. So it's a perpendicular segment. It forms a 90-degree angle from a vertex of a triangle to the line containing the opposite side. So the altitude will give you the height of the triangle, but the important thing to know about an altitude is it doesn't bisect anything. It doesn't create anything congruent. It merely comes from a vertex, forms a 90-degree angle, and will give you the height of a triangle. The orthocenter is the special point where the altitudes meet. The point of concurrency of the altitudes, and it can be inside, on, or outside the triangle. That's important to know about the orthocenter. It can be inside, on, or outside the triangle. Okay, so when we look back at a median, it's a segment whose endpoints are a vertex and a midpoint of the opposite side. Right, so a vertex and a midpoint of the opposite side. And the centroid is where the medians meet. And don't forget, that's the point, the center of gravity of a triangle, where you could balance something in a triangle. And the centroid has some special properties, right, in relation to the median. It's 2/3 from the vertex to the centroid, and then 1/3 from the centroid to the other side. And then again, we're going to talk about the altitude again. Remember, it's a perpendicular segment that goes from one of the vertexes of a triangle to the line containing an opposite side. And remember, it doesn't bisect, it doesn't hit at a midpoint, it strictly creates a 90-degree angle. All right, and it will help you identify the height of a triangle. The orthocenter is where the altitudes meet. It's the point of concurrency, right, where they meet of the altitudes. And it can be inside, on, or outside the triangle. Centroid, lots of special properties. Center of gravity, 1/3, 2/3, can be broken up into the altitude and the orthocenter. Give you height, and then the orthocenter can be inside, on, or outside the triangle. All right, guys, that's it for 5.4.